Hello guys and welcome back to my channel. Today is going to be one of the last videos of the TEDAC build series. From now on, I'm not going to show my build because we have finished the physical build and the only thing left is the connections, which is what I'm going to be showing today. So connecting the TDU to the enclosure, but after that you will have finished the physical build of the unit. And also I had to finish mine already for two reasons. Essentially, one is that I wanted to make sure everything was working as expected, and it is. And the second reason is that I was invited to a mission and I needed to be finished. But since, as I mentioned, the physical build is basically done and everything left to do since our last video is to connect the TDU to the enclosure. That's what I'm going to be showing today, and everything is going to be on screen. Today's video is going to be the connection diagrams for the 4 options. So there's 2 versions, 2 PCB versions, and 2 build processes, one with port expanders and the other with shift registers. So that makes 4 different variants, though in reality it's actually 2 methods, but it varies slightly from shift registers and port expanders. But this is what today's video is going to be about, and the next probably 2, I think I'm gonna do 2 videos to upload the software because they are so different that I'm gonna do one for shift registers. It's a totally different software, so one for shift registers and one for the port expanders. So that's the TEDAC build is almost over. So yeah, as you can see on screen, and sorry because I am not very good at drawing and editing images, so it's going to be very basic. But as you can see, here is the port expander version, PCB version 2.0. So here is the, let's say, the TDU. This is the TDU part, the PCB, and then we have left hand grip and right hand grip. And if you remember, if you build it using port expanders, you will have 2 port expanders here and 2 port expanders to the right. And in the left one, all you have is 4 wires, VCC, ground, SDA, and SCL. And in the right hand grip, you should have the same for the port expanders, plus 2 additional wires for analog inputs, plus at the very least 3 more wires that I told you we would need further on. So there would be 3 more wires coming out of the right hand grip. We'll talk about that in a second, but this is the connections that you need to do if you are using port expanders. And this part here doesn't change whether you're using 2.0 or 2.1. So every port expander needs to go to SDA at pin number 2 in the Arduino board, and SCL goes to pin number 3, which is this one, in the Arduino board. And you just connect them together. If you remember, you should have given each board a different address. So in our example, it was 20, 21, 22, and 24. And that's what makes the board it makes the board be able to identify what input is coming from where. So everything is connected together to the same pins. Obviously, the analog pins go to, analog inputs go to analog pins. I've put them here in A0 and A1, but it really doesn't matter how you want to connect them. So we are going to use analog pins A3, A2, A1, and A0, which are these 4 here. And it doesn't matter which ones go where. So I've labeled these ones as A2 and A3. As you can see, I actually put it with A1 and A0, and same goes for the 2 analog pins that are coming from the TDU. It doesn't matter, just plug them in these 4 pins and we will figure out what each one is later on in the software part. And of course, VCC and ground, you have to make it somehow that you can connect everything that it's VCC and ground. The port expanders will have one VCC and ground from the right hand grip, another one from the left hand grip, and then we will have VCC and ground which are labeled P and R in the TDU coming in. And if you remember from previous video, we used some sort of a power rail to do that. You can pigtail them or do whatever you feel. But they need to be connected to VCC pin, which is this one here next to A3 in the Arduino board. And grounds, we have three pins, three ground pins in the board. You can put them in separate ones, or you can daisy chain and put them in just one. It doesn't matter. All of these grounds are connected together. And so the three wires that are coming from the red the right hand grip that we are going to need are for, sorry, not this one, the rotary switch. This is the SR16 rotary switch, 3-position switch for the day, night, and off switch. So as you can see, and as we explained in the previous video, the center 2 pins are going to be, one of them is going to be ground. So we connect the center pin to another ground or to the same one, pigtail them, whatever. And the other 3 wires that are coming from the remaining available pins of one of the port expanders in the right hand grip are going to connect to each one of the 3 legs. And next connection that we are going to need, and I may disable others because it's going to be it's going to look a little bit messy, but let's try to show it. So next connection is from the TDU that we built in the last video. As I mentioned, B and R are VCC and ground, and A1 and A0 analog pins. And the next connection is going to be the button matrix. As I mentioned, version 2.0 is a matrix of 3 rows by 7 columns, and they are labeled R1, R2, R3, and C1 to C7. They are separated in 6-pin connector and 4-pin connector. But they are 3 rows and 7 columns. And the way you connect them is actually, so I've done this diagram connecting row 1, 2, and 3 to pins 4, 5, and 6, and then the columns are connecting to the next pins. Essentially, it really doesn't, because we can control that in the software. But the idea here is that you need how much is it? 10 pins. 10 pins more, 3 for the rows and 7 for the columns, and you just need to connect them to any of the remaining pins. Not many people know this. Let me just hide this again, not this one. But these 2 pins here, TX0 and RX1, are also valid pins that you can actually use, and we will use them for other versions. But essentially, what you need to do is, I have 10 more pins, actually 12 in this version, 12 more pins available, which are 4 to 9 in this side, and then 10, 15, 14, and 16 in this side. Essentially, what you need to do is connect these 10 pins to any of the remaining pins in the board. And as I said, I've done it like this. R1, R2, R3 to 4, 5, 6, and then columns 1 to 7 to 7, 8, 9, 10, 16, 14, and 15. But it really doesn't matter. Just make sure you write down or you know what each pin is used for. That's the only thing you need to know. Because we can modify that later on in the software. So once everything is connected with MCP, with the port expanders, because of the software that we are going to use, you could actually close the unit already. So put the screen in and close the screen, put the screws in the screen. I do, however, recommend to hold on to that, maybe just to make sure until we have uploaded the software, to make sure that everything is connected properly and that you know where everything is connected to. So maybe you need to revisit the inside of the board. So maybe hold on to closing, but you won't actually need to access it. If everything is correct, you won't need to access it. It's not the same for the shift register version, even it uses the same PCB, but since the software we are going to use does require you to reset the Arduino board once. So even though when you have connected everything, I mean, I expect you you should have all these connections here from the TDU to be with long enough wires that you can still, if you don't screw it together, you can still move it around and access the inside of the enclosure yet. You can even hold on to putting the screen, the LCD screen, and wait to do that for the last time, and therefore you would have an open gap to access, because for shift registers you will need to access the Arduino board while programming it. So this should not be here, but essentially it's the same. This is the shift register version, as we've talked about in our previous videos. We should have 4 shift registers in the left hand grip with 5 wires in this case coming out of it. And then we should have 3 shift registers inside the grip and a 4th one that we put inside the enclosure. So there's also 4 shift registers in the right side, let's say. Again, with 2 analog wires coming out. And I actually did this the same as I did for the port expanders, but if you remember, these 3 wires actually are not coming from the right hand grip, but from the 4th port expander that we added inside the enclosure. If you build it with shift registers, you should have, there are 23 inputs, so you should only have 1 available pin. You don't need that if you are going to add another shift register inside the enclosure. But you wouldn't have 3 wires coming out of the right hand grip because there's not enough pins there. So we added a 4th shift register inside the enclosure, and that's going to be used for these 3 connections for the rotary switch. And if you want, for the extra buttons on top that are optional, and we talked about that in the previous video. I didn't mention them in this one, but in this build with the port expanders, you have actually 9 pins available in the right hand grip. So if you want to use optional buttons or switches on the top of the enclosure, you just need to take a few more wires than these 3. So you have up to 9. You need 3 for this, and then the other 6 you can use for the additional optional buttons if you want. So yeah, that being said, the connections are essentially the same. Same here, 2 more analog pins, VCC and ground. Sorry, I didn't mention it, but 5 wires. This option is going to take a few more pins, but it's okay because we have enough. So not only it uses 5 wires, there are 5 wires coming out of the shift registers, but the data pins of each if line, not if shift register, if series, so there's 4 here, that's going to use 1 data line that is going to pin one of these pins. And this series of 4 shift registers to the right are going to use another data line that is going to be connected to a different pin. So it's taking 3 more pins in this case, 2 for the data and then another for clock and latch. So clock, as I mentioned in the previous video, for every single, I mean, this clock and latch can be tied together. Data are the ones that need to be separated, but clock and latch can go together and actually have to in order to have enough pins in the Arduino board. Clock has to be pin 15, which is this one here. And this is because the software that we are going to use does not allow us to select what pin of the Arduino is going to be clock. The software only asks us for the latch pin and the data pin, and clock pin has to be the internal clock pin of the Arduino board, which is the pin number 15. And then latch, just because it's beside it, I decided to put it in 14, and data to 16 and 10. But again, latch and clock, you can use whatever available pin it is. As before, analog pins to A3 to A0, and VCC and ground are exactly the same. And then, as I mentioned, the idea is that the button matrix of the TDU have to be connected to the rest of the pins, to the available pins. And as I mentioned, not many people know, but these two pins are actually valid digital inputs. Not many people know. So if you didn't, you could have thought that we don't have enough pins, but we actually do, because we can use those two as well. So that's what I did. I essentially connected everything to the available pins. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on, I'm missing one. Oh, there's. Hold on. 5, 6, 7, 8. So there's 8 pins here, and 2 more pins here. That's the 10 pins that we need. And again, it doesn't matter. You don't need to follow this order exactly. Just connect them wherever you want of the available pins. And we will control what each of these pins do in the software. Again, if you want to use the optional buttons, since we added a fourth shift register, of which we are only going to be using 3 of the pins, we still have 5 more pins of that fourth shift register. So now if we go to version 2.1, if you remember, I mentioned that that's not a button matrix. The TDU PCB in version 2.1 is actually one single button. So it has one pin for each button in the PCB. Everything else is the same. I added the addresses here in this case, because for this version we are going to need, we will need to add more connections. So there are 21 buttons in the TDU. That means that for version 2.1 we need 21 additional inputs. How do we get that with port expanders? Well, there's several options. First, everything else is the same. We have for 2 port expanders in the left-hand grip, we have all of them covered. There's 32 inputs, so they are all used. In the right-hand grip, as I mentioned, we have 23 inputs. With 2 port expanders, we have 9 available pins. 3 of them are going to be used for the rotary switch. Then there's 6 more available. So what that does mean? That means that you could add only one more MCP, one more port expander here, and use 6 pins here and the 16 pins here. That's 21 pins. Sorry, 22 pins. That's basically what you need, all what you need. So you would need to get all the pins used in the right-hand grip and take wires out of the right-hand grip for those pins, and then use them in the MCP. I have not added lines here because that would be essentially 21 lines going all over the place, but I think you get the idea. So there's an additional MCP that you need, and I gave it address 23, but you can give whatever address that you want. You just need to remember what addresses have you used. And if you don't worry, there are Arduino sketches that detect I2C devices and can give you the connected addresses. But anyway, you would obviously connect this same way, so VCC and ground with the same connections, and SDA and SCL. The good thing is that you don't need additional pins for that. So you would connect out of the 21 connections in the MCP, you would connect them 16 of them to this additional port expander, and the other 5 to the available pins in the right hand grip. Or if you want, you can just add 2 boards and give it another, because you can have up to 8 of these, and with this solution you already have only 5, so you could add a 6th one, just not to get the wires coming out of the right grip, which is not a big problem. But if you just don't want to, or you have already built the grip and you don't want to dismantle it again and add new wires, you can just add a 6th port expander, and then you would have 32 more pins. But it's not needed. It's not needed, and the reason I say this is because if you do it like this with just one more additional port expander, you may say, well, but there's only going to be one available pin from this right-hand grip, and I wanted to add a few more additional buttons, like the ones I mentioned that are optional in the enclosure. I want to use them. Well, the thing is that with this method, you are not going to use any of these pins. We don't have to use them for the button matrix. So all these pins are available. So you can connect those pins directly to the remaining pins. I'll show you how to do that, because it's not as simple as just connecting them. But I'll explain you how to do that when the software part comes. But actually, never mind. With MCP, you can connect just the buttons. So you would need to connect whatever additional button you want to one common wire to ground, and then the other leg connected to any pins available here, which are a lot. And then I don't have a version for shift registers because it's essentially the same. So what I did, I built mine with shift registers, essentially the same. So as I mentioned in the previous video, we added a 4th shift register inside the enclosure. What I did is add 2 more next to it. So I essentially have 3 shift registers inside the enclosure. So in those 3 shift registers that are inside the enclosure, if you remember from previous video, I had only connected 2 pins of that 4th one for the 2 additional switches that I have on top of the enclosure. In my case, I only needed 2, so that means I now have 16 plus 6. I have 22 available pins, and this switch over here is actually going to be connected directly to the board. So I don't have a schematic, but I'll tell you how I connect them. But just ignore it for now. So I have 22 available pins, which are connected to the 21 pins of the TDU, right? And then lastly, this switch that needs to be connected, and I'll tell you why when the software part comes, but you need to connect one leg to one of these available pins. Again, all of these pins are going to not be used, so anything, I think I connected it to maybe pin 4 or something, or maybe pin 6, and then the other 3 to 7, 8, 9, right? So all 4 pins are connected to the board. So yeah, and I'll explain why in the software part. But this is the connection diagram. Again, if you are using the shift expanders, do not close it, because when uploading the software into the Arduino board, we will need to access it. There's a step that needs to ground, reset, and ground to connect, reset, and ground to reset the board at some point. So we need to have access to the board. I hope it won't take long to do those videos, since I don't have to physically build anything. Everything I have to do is essentially comment in front of the computer and show you how to do it. Again, I've already built mine, so I'm going to be showing how to do it, but it's not going to be, I'll probably connect maybe a potentiometer and a button or two just to show you how it looks like, but it's not going to be the actual one because I already built mine. So I'll have something prepared to demonstrate how to do it, but it's not going to be my actual TEDAC. So yeah, looking forward to show you that and finally finish the series, and see you in the next one.